Hello, everyone. My name is Tizghadam. I'm a principal technology architect at Telus. As the chief architect of our network authorization strategy, today I would like to share with you some of the obstacles in our journey towards network authorization and explain how we converted them to opportunities for growth. Before getting to the details, though, who is Telus? For those of you who may have not heard, Telus is one of the largest telco service providers in Canada, operating nationally from East Coast to West Coast. In last few years, Telus has been constantly chosen as the fastest mobile network in Canada, and just last month, OpenSignal identified Telus as the fastest in the world. Telus has been always a leader in sustainability, and it is the first Canadian company recognized as the world's most outstanding philanthropic company. With that introduction, let me start off by summarizing the current battleground in telco space. From a holistic view, telco service providers are transitioning to a new era. The type of services are changing. Traditionally, in telco-based service providers, we have had services with long lifetime, such as voice, TV, and data. Nowadays, new services are required, which are more dynamic and typically with much shorter life cycle. One example is bandwidth calendaring. To address the new requirements, we need to build an ecosystem comprised of a programmable infrastructure accompanied with a platform to enable quick and automatic reshaping of the network, including its traffic. Moreover, the ecosystem has to offer an intelligent service and application development framework. With that in mind, let's first review the evolution of telco service providers from network architecture perspective. From that angle, Telus and pretty much all other carriers have gone through 5 stages of change. In 1990s, all services were having their separate network infrastructure and separate service delivery points. At the beginning of 21st century, MPLS enabled deployment of converged core, but the service edges were still separate. Towards second decade of the century, we started witnessing convergence of service edges. In fact, Telus was among the first around the globe to unify service delivery edges. In the midst of second decade, the deployment of programmable network infrastructure in optical and IP layers started. Programmable optics was emerged by introduction of CDC technology, enabling software control on optical capacity. And in the IP layer, segment routing was the initiator of the next level of programmability at the packet level. The next move that is starting and probably will be continuing to grow till the end of the third decade is the move towards smart edge. Meaning after core programmability, now we make edge programmable using concepts of disaggregated networking. Parallel to building programmable infrastructure, there has to be a platform to enable creation of services and applications over the top. In Telus, we have developed our in-house ecosystem called TINA for this purpose, and I was honored to architect it. TINA stands for Telus Intelligent Network Analytics and Automation Ecosystem. In summary, it can be considered as a network operating system for automation that provides a framework with a set of generic and vendor-agnostic APIs to enable creation of innovative and fully closed-loop controlled applications. In principle, it includes 5 major blocks referred to as a MAPE-K loop, where a MAPE-K stands for monitor, analyze, plan, execute, and knowledge base. Each block has different independent plugins to enable the required functionality that is obvious from the name of the block. And there is also an abstraction layer in each block called mediation layer. The role of mediation layer is to hide vendor-specific and technology-dependent details from northbound and offer generic data models exposed through APIs. Tina deployment follows cloud-native principles. Plugins in each block are extensible and scalable microservices. Therefore, we can enrich functionality of each block without impacting the performance. The focus of this talk is on challenges we have faced on and continue facing in going through our network softwareization journey. One of the major bottlenecks and issues we are dealing with is the existence of legacy infrastructure. There has been a huge investment for all telco service providers to build their current infrastructure. And if we want to go through the full deployment of programmable infrastructure and service delivery platform, many of the existing toolsets and devices have to be replaced. There are inventories, element management systems, simulators, gigantic service routers, a large set of existing processes, different traffic collectors, and more importantly, style of thinking and daily based habits built around it. While our intended mode of operations is a kind of clean slate, model-driven and automated way of network management, it comes with some requirements which cannot be easily met with our existing deployment. So the billion-dollar question is this. Can we make everything look like greenfield without retiring brownfield deployment? The answer is cautiously yes, and this is where the mediation or abstraction layer of TINA is strongly coming to the picture. In the next few minutes, I'm going to walk you through some of our challenges and discuss how we are trying to deal with them. I'm positive most of audience have gone through some sort of transition from a command line based interfacing with different entities to a model-driven approach. Model-driven involves creating generic data models that can be referenced within a program to manage the changes that are supposed to be applied to an entity in the network and provides maximum flexibility in automating network change deployments. In Telus, we have started to use model-driven approach to automate the network deployment for a while. As an instance, the day zero of new greenfield devices are handled with a TINA application that can be onboarded, that can onboard an entity with its associated data model and push the initial configuration of the entity, including uplink devices automatically. While this application saves a lot of time for bootstrapping a device, it comes with challenges. And the operations team is very much attached to the CLI approach, and they would like to have direct access to the device and configure it themselves using CLI. In the visual part also, they would like to see everything in CLI form and not in YANG or JSON format. In current deployment of the application, we have created a governance process, and with that, when a day zero deployment is planned, after initial input and preparation of the model by application, we show the intended config in both JSON and CLI forms for operations approval. And even for deployment of a part of it that needs to deal with uplink devices, we do not automatically push it to the uplink device, given that it is an active device. Instead, we provide the CLI for intended config, and we let the operations decide if they want to copy the config and deploy it themselves or push a button for automatic deployment. The other fact in our automation journey is the following. We cannot be certain that after launching the automation app, the whole team is only using the application. There are still some direct device changes using CLI, and that is where mediation layer of TINA helps us. As shown in the picture, we have a synchronizer microservice deployed within the execute mediation layer. The synchronizer periodically checks to make sure the config in database is synced with the device. And in case it finds it out of sync, it will update the database. As another issue, we can talk about some more toolset and plugins like legacy inventories or element management systems and other their associated databases. We need to enable northbound applications to use the legacy database over the top, using the same generic APIs exposed for greenfield inventory actions without any need to develop a separate software. To this end, we need to create an abstraction or mediation layer on top and extend the coverage of greenfield generic APIs for them. This way, we enable smooth and seamless migration of the legacy inventory. At the same time, we provide for inventory federation functionality. For example, if plugin 1 in the diagram is a legacy inventory and we would like to replace it with a new modern inventory presented by plugin 1N in the diagram, the first step is to add a new plugin and integrate its APIs with the generic API set that we already have by applying the required mapping logic, if any. Then we can start migrating parts of old inventory and using the mediation layer as a gateway. If the request from the application is coming from the migrated data, the new plugin will be involved. In this case, also, there are a set of existing processes and users of those processes would like to continue using the existing inventory with its own software and portal. Similar to our previous discussion, mediation layer offers synchronization capability to make sure the changes that are applied by users of old inventory will show up in the new one as well. As the last point on mediation layer, I would like to emphasize on another use case in which mediation layer helped us nicely abstract brownfield. In new devices, we have telemetry enabled, meaning that we can define what statistics we need from the device and how frequently. It will be then streamed to us from the device. In brownfield devices, we need to do polling from KPI collection as telemetry is not supported. We have used the content-based publish subscribe middleware to kind of convert SNMP or CLI polled data in TINA to streams that can be published. This way, applications can subscribe to that data similar to how they subscribe to telemetry. Another reason for slowness in transitioning from brownfield practices to clean slate or greenfield practices is reliability issues. Obviously, with any new disruptive technology, we increase risk of failures at the beginning due to many unknowns around the technology. Change management is one of the places that is heavily impacted by the new wave of automation. On one hand, change management has always been about a manual and careful, slow governance before any change gets deployed in the network. On the other hand, automation is all about removing manual processes and speeding up the deployment. Particularly, the softwareization of network comes with one major paradigm shift. The network engineers and architects are not the consumer of a black box anymore. They have to contribute in developing software as well, and this is a growing need. But it is at odds with most of the habits of operations teams and architects. We have been trying to address the gap in change management by guaranteeing the rollback feature or reversibility of every action along with creation of detailed logs for each action. Moreover, we try to deploy the concept of reliability by design or reliable by design, not just into the network architecture, but to the software as well. To this end, sophisticated CI/CD pipelines with proper testing in different stages have been created. Moreover, in our software development, we have tried to make test-driven development paradigm or TDD a culture. TDD means the developer has to create unit tests before writing the code for a target software module. TDD approach helps catch the issues in requirements and in the code early on. Another interesting challenge in the journey towards network softwareization is in architecture design principles. There are two schools of thoughts in architectural design: bottom-up approach and top-down style. Traditionally, network architects and engineers are raised within a bottom-up culture, where you start from device and its specification and you grow it to a network architecture. The top-down approach starts by having requirements from users' perspective and finds out what that means to the lower layers. In model-driven world, top-down design approach is what we require, which is at odds with how most of network architects think. A related topic is platform versus use case oriented design. One school of thought is to define a use case and build a product to cover the requirements of that use case vertically. Over-the-top application deployment, though, requires a supporting platform to enable fast creation of applications without being worried about underlying layer details. So a mindset shift was required. To address that, we went through extensive training, experience gaining, debates, and obviously patience and tolerance. Let's now shift our attention to another important domain. In network planning and capacity management, traditionally the engineers work based on measuring link loads or link utilization. There are typically thresholds defined for link utilization, and when the traffic is above the threshold, the capacity management team issues capacity upgrade. The request goes to the planners, and they will plan the network changes accordingly. To be proactive, the capacity management team is usually having manual utilization forecasts to predict the time for capacity augment. There are many manual processes involved here, and changing those processes are very hard. In the world of SDN, and with the capability of engineering and orchestrating traffic for IP and optical layers automatically in a unified way using software, we need to change many things. First, the link load-based approach needs to be replaced with end-to-end demand-based planning. Second, the forecasting needs to be automated and used together with network discovery as an input to network twin, where an offline model mimicking the exact production network topology can guide the practice and help understand what needs to be done. While this is an exciting movement, it comes with a huge investment on educating people, gaining trust, and shifting mindset. The last topic I would like to touch is DevOps. While DevOps is becoming more mature, I still consider it as a buzzword. There are many definitions for DevOps. According to one of them, DevOps is a cross-functional community of practice dedicated to building, evolving, and operating rapidly changing, secure, resilient systems at scale. From another standpoint, DevOps is marrying of process, infrastructure, and product. You cannot buy DevOps, but you may need to sell it internally. However, selling DevOps is hard because it is a new culture and it is about a significant change in how you operate. DevOps is about managing the change, but what is changing here? Looking outside of the box, DevOps is about managing the lifecycle change, applications with short lifecycle versus platform and infrastructure services with long lifecycle. In order to be successful in delivering true DevOps, separation of concerns between these two domains has to be fully practiced. This speaks to another major challenge we are facing. Network engineers are historically looking at the issues vertically across the board, and it is hard to convince them to stick to the domain of concern. Another challenge in building DevOps culture is to have development and operations teams talk to each other in a constructive way. They have different interests. Development wants more change and operations need less. So there has to be a method to introduce changes in such a way that from the beginning and automatically operations is involved and works hand in hand with development team. The best solution that we have found in Telus to deal with this issue is to introduce DevOps data model. That includes all parameters of interest in a project from ops perspective as well as development or architecture. Okay, let me stop here before I disappoint you more. While we have faced all of the challenges that I discussed here, but they are kind of present issues to tackle in the network softwareization journey, in my opinion. And I'm grateful that I have been a part of it. Please feel free to reach out to me in case of any questions. My email is right here, you can see it. Enjoy the rest of the conference, and wherever you are, please stay safe. Thank you.